All right, guys, here we go. We're going to focus on the easier integrals, the easier ones. All right, guys, focus. So remember before the break, before the semester exam, or before the end of the semester, we said that integral, indefinite integral, there's no limits on the top or bottom. This is all we know right now, of f of prime of x dx equals f of x plus c. Do you guys remember that? No. Oh, we did it before the end of the semester. That's a dx. Yeah, look, we did it, guys. Don't tell me that we didn't do it. Okay. All right. So here we go. You guys ready? That's all we're doing. This is all we're doing, guys. So all we're doing is finding the antiderivative. So you see this integral here, and it says 4 over x to the 7th dx. This is your f prime right there. See? And we're doing the antiderivative of that. So make it where you can make it, rewrite it so it's easier for you guys. 4x to the negative 7 dx equals, and I'm going to go slow. So we got to reverse the operation and do the inverse operation and reverse the order. So add 1 to the negative 7. What's that? Negative 6. And then we're going to divide by that negative 6. Because remember, before we multiplied and subtracted. So now you add and divide. Do you see how we reversed and did the inverse operation? And then put plus c. All right, so let's see. This 4 and that negative 6, do they reduce? Yes, I'm going to put the negative in the front. 2 goes into 4 how many times? 2. 2 goes into 6 how many times? 3. And they probably want you to rewrite it. So that x to the negative 6, you can bring it down. And it's x to the plus c. Do you see that answer anywhere? Yeah, this one's already been done. It was done this morning, 7 a.m.
Did you do it?
Yeah, really quick.
You got all of them right?
Miss, why would I not? Come on. I hope your whoever's teaching you calculus should get them all. All right, here we go. Yeah, well, it's not my first rodeo. So. Yeah. All right, here we go. This one, don't freak out, Chop. I don't know how to do this one. You see how you're only dividing by one term? So go ahead and break it off like this on the side. Go 6x cubed over x squared minus 3 over x squared. You can do that. As long as it's just one term, you can do that. Are we okay? All right. How many x's can I cancel here? 2 of them. So you only have 1 left. And then this one, I'm going to bring it up. So it's going to be easier for me to integrate. Yep. So I have 6x minus 3x to the negative 2 dx. You don't have to put parentheses, but it's understood that it's the end. The dx marks the end. All right, so here we go. Antiderivative of 6x. Add 1 to the exponent, divide by that exponent. So what is it? Yep. So 6x squared. I'll write it because we're rookies now. 6x squared divided by 2. If you feel comfortable, just write 3x squared right off the bat. And then minus 3x. Add 1 to that negative 2, which is... and divide by that negative 1. And don't leave it like that. You got to put a plus what? Plus c. Some c. Because it doesn't have a constant on your limit, on your integral there. So what's 6 divided by 2? So 3x squared. Negative divided by negative? So plus 3 over x plus c. Is that answer in there? Yes. How are we feeling so far, guys? Okay. Let's go to the next one. Chav, I can't do this one. Yes, you can. Turn everything into an exponent. You've had algebra before. So here we go. Integral. 6x squared plus 3x to the half plus x to the negative, close it, dx equals, and I'll go slow. Yeah, add 1 to that exponent. So 6x to the what power? 3 divided by 3. If you want to just write 2x cubed, that's fine. But, I wouldn't do that until you start becoming like a boss. So here we go. 3x to the, so add 1 to the half. 3 halves divided by 3 halves. But instead of dividing by 3 halves, I'm going to put a dot here. And I'm going to go, yep, by the reciprocal. Does that make sense? And I'm going to put a little arrow here for good notes. Same as dividing by 3 halves. But we want to get into I don't want you guys to have that habit. As soon as you see a fraction, I want you to just multiply by the reciprocal. Are we still okay? Yes. Plus, add 1 to that exponent. What's negative 3 plus 1? X to the negative 2 divided by negative 2. Perfect. And then put a plus c. All right, let's see what this is. 6 divided by 3 is? So 2x cubed plus, what's 2 times, well, the 3's cancel out. But it's the same thing. 2 times 3 would have been 6. 6 divided by 3 is 2x to the 3 halves. Oh, I wrote 3 halves. And then positive divided by negative is so 1 over 2x squared, where the x squared is on the bottom, plus c. How do we feel? Perfect. Make sure you do these by hand, guys. Though you want to get a lot of practice with these because it is what we're going to be doing all this semester.
Is this what the whole UH is?
For this one, yes. That's why we call it kind of like a easy one because, so we're giving you a break. All right, here we go. Let's rewrite this. I'm just rewriting the inside. So here we go. Integral 3x to the half minus x to the negative half plus 7e to the x dx. Are we still okay? All right, here we go. Yeah. 3x, add 1 to the 1 half. What's that? 3 halves divided by 3 halves, which is the same thing as multiplying by 2/3. So I put a 2/3 in the front with a little dot. You guys see how we did it? Okay. Minus, and then add 1 to the negative half. That's going to be what? 1 half. And then divided by a half, which is the same thing as times 2. So you can just put the 2. Yep. That one looks funny. So there we go. And then derivative or antiderivative of 7e to the x is going to be itself. Those are going to always be the same. Plus c. All right. Let's fix this. The 3's cancel out, or 2 times 3 divided by 3, so you'll get that 2 anyways. 2x, perfect, minus 2. That x to the half, they're probably going to write it as what? Square root of x plus 7e to the x plus c. Is that in there, guys? Yeah, it's not that bad, right? All right, here we go. Yes. Do you want me to go back? Okay. We're good. Damn. Sorry. LOL. No. Hey, okay. Miss, stop. Don't even. I did not. Let the record show I am up here teaching. All right. Here we go, guys. Here we go. So it's up to you if you want to show the integral symbol or not. See how it says f prime is this, and they want you to find, it says find f. So I'm just going to go ahead and go right into it. F of x equals, what's the antiderivative of 2x? 2x squared divided by 2. So x squared, if you want to just write that in there, minus what's antiderivative of 4? 4x, and then I put a plus c. And then remember, we did this exactly last semester, this right here. This is my initial condition, or when x is 2, the y is negative 1. So I'm going to plug this in to get my c value. So I'm going to go negative 1 equals, I'm going to go ahead and cancel those 2's out. Is that okay with you guys? No? Oh, okay. 2 squared minus 4 times 2 plus c. Have I tricked anyone? All right, here we go. Negative 1 equals 2 squared is 4. 4 times 2 is 8 plus c. Now it just turns to algebra. We're no longer doing calculus. What's the difference between 4 and 8? Negative 4 plus c. And then what do I do with that negative 4? Plus 4 plus 4. So now I get positive 3. No, you're good. You're good. So now that I know that c is 3, plug it in back to the original. So my f of x equals x squared minus 4x plus 3. Does everyone see how we did it? So there it is. X squared minus 4x plus 3. Okay, here we go. It's not extreme pre-cal. Bless you. Base c squared. That's c cubed, in case we got another one. Oh, okay. We just had 2. Baby pre-cal, guys. F of x, what is, okay, we might get, let's go slow. Don't look at the answers. The derivative of cosine would have been negative sign. But am I doing derivative or antiderivative? Antiderivative. So the antiderivative of cosine is just sine. That's a constant. Leave the constant alone. So 4 sine x plus c. Chop, how do I check yourself? Here's how you check yourself before you wreck yourself. I'll stop. What's the derivative of 4 sine x? 4 cosine x, and there it is. It works. You see how we did it, guys? And the derivative of a constant is 0, so it goes away. All right, we use our initial condition. They're telling us when the x is 0, the output is 1. So I'm going to go 1 equals 4 sine 0 plus c. So a little bit of pre-count, just baby pre-count, not extreme. Sine of 0 is 0. It's a y value at when the radian is 0. So this goes away. So what's my c value? 1. So that means my f of x is 4 sine x plus 1. And oyan, that's a demerit. Are we okay? Can we go to the next one? I wonder why.
Why does it say pi?
I know. That's what I was wondering. I guess they couldn't put the symbol out there. Well, okay, that's fine. All right, find f of x based on the following information. So the second derivative is cosine. F of pi is 4, and f of 0 is 2. So you're going to have to do it antiderivative twice. That's all it means. So here we go. I'm doing antiderivative from f prime prime. So that's f prime. What is the antiderivative of cosine x? Positive sine x. And then I put a plus what? Plus c. They tell me that f prime of pi is 4. So that means I'm going to equal this to 4 when x is pi. So 4 equals sine pi plus c. I'm slowing down. From pre-cal, sine pi is 0. So that means c is 4. So here it is. F prime of x is equal to sine x plus 4. So catch up to here. I don't know if you have room on that page. I'm lucky because I can just see my next page right here. So I'm just going to write it here on the top. I'm just going to do antiderivative of that. So here we go. F of x. What's the antiderivative of sine x? Negative cosine x. Yep, because if you take the derivative of cosine x, it's negative sine x. So they have a negative times the negative.
Plus 4 or plus c?
No, plus 4x because they're doing antiderivative.
Oh, okay.
And then I put a plus what? And now we plug in the 0 and 2. So 2 equals negative cosine of 0 plus 4 times 0 plus c. The 4 times 0 goes away. Cosine of 0 is 1, but I have a negative in the front. So what is c? There you go. Plug in that c right there. So look for that answer. It's on the front page. Are we okay, guys? All right. This one you're just going to have to recognize. But relax. It's not even that extreme. Yeah, the formatting didn't come out kind of weird. That's fine. No big deal. Remember, I'm going to put here, remember, arc sine of u is 1 over the square root of 1 minus u squared du dx. Remember that. So as soon as you see a square root 1 minus x squared or 1 minus something squared, you should be thinking this. So this answer, that 3, if you want, you can put it to the front. 3 integral 1 over square root of 1 minus x squared dx. Maybe we're not good enough to do that just yet, but I hope that we can. It's a constant. Yeah, 3 times that, and I could have put it in the top. If it's a constant, guys, if you're not comfortable to do that, then that's fine. Don't, leave it. But recognize it. I just wrote it like this so you can recognize it. See, 3 times that. That makes sense.
It's like putting it in parentheses.
Yeah. So you see, 3 times that goes right to the numerator. Oh, you can only do that with a constant. If there's a variable, you cannot do that. 3 arc sine. Yep, arc sine of x plus what? C. There it is. That's what the answer of that antiderivative is. So the answer is B. They're not going to give you any hard ones, guys. It's always going to be like that.
So we just need more properties.
Yeah. This is not tested on the AP exam, but derivative and that H, what is that H? Hyperbolic. If you're becoming a physicist or a mathematician, you will need those, or engineering. But it's not tested on the AP exam. The derivative of any hyperbolic function well, trig, sine, cosine is always going to be positive. So you know how the derivative of cosine is negative sine? The derivative of hyperbolic cosine is just hyperbolic sine without the negative. Does that make sense? So
the h will always be there.
yeah, the h will always be there. So look for a cosine hyperbolic, and then that we can do. What's antiderivative of x to the 7th? X to the 8 divided by 8. So look for that. Do you see it? What letter? D. So the antiderivative of hyperbolics, will they ever be negative? No. So there it is. There's a free one. That one should be pretty easy for you guys.
Oh wait, so if we have like cosine hyperbolic of x, could we get negative sine hyperbolic?
Nope. They're always going to be positive.
Wait, I think yesterday at AntiDerivs, like the strawberry said hyperbolic strawberries.
Do you know what hyperbolic?
No.
What?
I was like, what is that?
We'll talk about it.
That's what it was.
Oh yeah, so that's not the same as hyperbolic. All right, here we go, guys. Last one. The 1 over x, leave it alone. Why? What's the antiderivative of 1 over x? I know you know, that's the merit. ln, natural log. Do you guys remember? Okay, so that one is natural log. So leave that one alone. So here we go. I'm going to go integral of 1 over x. But this one, these two I'm not going to leave alone. Minus 2x to the negative 2 plus 2x to the negative 3, and then put the dx. And if you want to put parentheses around the whole thing, you can. It's up to you, though. That's like f of x times dx. Y'all ready? Antiderivative of 1 over x. What's that? ln of x. And then what do I do that negative 2? So I'm going to write minus 2x to the negative 1 divided by negative 1 plus 2x to the, no, not negative 4. Negative 2 divided by negative 2 plus c. So let's see what this is. ln of x, negative divided by negative, plus 2 over x. So that brought that x to negative 1 down. Positive divided by negative. So minus x, bring it down. 1 over x squared. And I brought it down. The 2's cancel out. Plus c. Is that answer in there? All right, that was it, guys. There's a delta. Do the delta first. And then the UH is not due till the end of the week, but you can see it's pretty easy, right? So that's it, guys. Do the delta first. It shouldn't take you too long.